This is just a quick review of some notation that you have seen before. Um, no difference between this notation um, and what you've seen in past years of EAC. So like for here, first you can see some different parentheses, brackets, and braces. The way they call these might be different because it's kind of European, but I mean, there's not really any difference in meaning between the square brackets and the round parentheses. It's just like, they kind of go together. So, like, for example, it just makes it easier to use a different combination of brackets and braces because, if you have something like this, where you have, 2 plus 4, and here you have 3 divided by 2, and this is minus. So this is like, you can see more easily that this round one goes with this round one, this round one goes with this round one, and this square one goes with this square one because you've used a a combination of different ones. You could also use like these on the outside. But they're all just different parentheses, and you just basically pair them together to understand. Oops. You just pair them together just to understand what you're doing there. Okay? It's like this goes with this. This goes with this. See? Okay, so decimal point. No mystery in that, right? 3.4. The only tricky thing is that, remember, in Brazil, you use comma, and don't get mixed up. Try not to use comma in your IB class. In some cases where it's not confusing, they'll accept it, but sometimes it can confuse you and other people. So make sure for decimal you just use the point. Thousand separator, the comma is used for 1,000 separators. So for example, 300,000, you write like that, right? Oops. 300,000. Oops. I haven't gotten used to this pen. 300,000. Okay. Let's go down a little bit. Scientific notation. So scientific notation, I'm just going to talk about the notation here, not how you use it. There's always the beginning here, which is a number between 1 and 10. Okay, so not as anything less than 10. Okay, so you can see it's like less than 10, something greater than or equal to 1. So you could have like 1.01, you could have 1. Can you have 10.3? No, you can't. That's too big. The biggest number you can have is like 9.999. Okay? So you're always going to use a number here between 1 and 10. And then you're going to multiply it times a exponent, 10 to the fourth power, for example. Okay, and remember that this z here means integers, so positive or negative whole numbers. Oops. Okay. Messed up again. Okay. All right. Set theory. Set theory is something that you probably had when you were very young. Set theory is like, okay, what animals are in the set of four-legged animals? Like there would be dog, there would be cat, okay, etc. Something like that. And then you also have the set of um, animals without tails or something like that. So what would that be? Maybe like, well, a bear has, let's say a bear. Okay, so a bear has a really short tail. So, and then maybe he's in this set too. Okay, he's also in the four-legged animal set, and he's also in the, short tail animal set. And then, so remember what union and intersection do. They kind of like figure out, okay, the union, if you take the union of this set, four-legged animals, and this set, short-tailed animals, you're going to get everybody. So it like every single animal that is in either set it'll put them here. So that the result would be dog, it would be cat, it would be bear. Okay? The intersection, you just want to find things that are both in four-legged animals and short tail. So then it would be just bear, right? So intersection just looks at things that are in both sets, and union looks at things that are in every single element in either set. Okay, roots and absolute value. We're just going to talk about the notation here, not how you do it. We can talk about how you do it later. Okay. Okay, so like for example, when you have a to the power of, and you have like a fraction thing here, this is actually the same thing as saying um, the nth root of a. So remember that a to the 1/2 is equal to the square root of a. Okay, so a to the 1/n is equal to the nth root of a. Okay, and then the negative here, a to the negative n, it just inverts everything. Okay, so it takes the rest of it, a to the n, and then it just puts it here in the bottom. Okay, and I just did this one above top. And remember, absolute value just means, okay, if it's a negative number, absolute value will change it to a positive number. And if it's already positive, then absolute value does nothing. Okay, and that's basically what this is saying. When it says x is an element of, and it has a script r here, it's saying x is a real number. So any real number can be put into this function. Inequalities. You guys have known these for a long time. There's different ways to remember it. Remember, like this is like the alligator eats the bigger number. Okay. Greater than or equal to means that, okay, even if it's 3 and 3, it's still true, right? Is 3 greater than or equal to 3? Yeah, it's equal to. Okay. Now, is 3 greater than 3? No, it's not. Okay. Less than or equal to. Okay. Function, trigonometric functions, and triangle. Okay, so function, you may not remember exactly what a function is, but the notation is like this. F, the function f, which is a function of x, which means this is the input. So x is the input. It doesn't have to be x, but in this case it's x. Okay, so the input is the variable x. The name of the function is f. Okay, so the image of x, which is the input under the function f, for example. Sine, cosine, tangent. You probably remember these, although you might not remember exactly what they are. Sine, cosine. If you write them out, they look like this. But the 3 first letters are the abbreviation. Triangle ABC, that means a triangle who has the corners or vertexes. Oopsie. Okay. Sorry about that. A, B, and C. Statistics. Okay. Just for now, just remember that these both are kind of ways of saying average or mean. Okay. They're not exactly the same, but you don't really have to know the exact meaning. They'll be the ones that are going to use the right term at the right time. Okay. Basically, a set of data is something that's just like, a bunch of numbers you have. Population is like a huge amount of people to sample, and you only are going to take a small sample of the millions of people. A set of data, you have all the data, okay? But you don't need to know that. Sigma is the Greek letter for S, and it looks like this. And just remember that sigma is standard deviation. Okay, it looks kind of like an R, but it's actually the Greek S. And that's it. Okay.